Hello, everyone, and welcome back to our series on urban energy modeling with Dragonfly. And in the previous video, we worked to assemble this Dragonfly model of a single building, but with detailed zoning, which you can now see in the Rhino scene right now. And while we were able to assign individual zoning properties, individual programs to different rooms of this building using our rooms to stories to buildings workflow, there are still some properties of this model that I think we need to check to be sure that it's good enough for an energy simulation. So in order to do this right now, I'm going to do a very similar process we did for our other Dragonfly models we built in this series. I'm going to translate the model to Honeybee so I can really understand what's going on when I export this model into a 3D format for energy simulation. So all right, I'm going to grab this DF model to Honeybee component that I have here. I'm going to connect up my Dragonfly model that we've created of this office building. And let's see, and I'm just going to set this to run as it is right now because it's just one building. I think the default object per model is fine. I don't need to do anything special to this. We'll just get one Honeybee model out of this because we have one building. So let me double click and set this to true. So out of this component, we are getting a model that bears the same name of our building that we set in here, Science Center. And then in order to preview this in the Rhino scene, preview the actual 3D geometry more than just these 2D floor plates and their properties, I'm going to drag and drop this HB Visualize by Type component on the canvas. Okay, and I can connect up my Honeybee model here to make sure that I don't have things previewing on top of each other. I'm just going to turn the preview off on this color room 2D attributes. So I'm going to right click on the center and select preview. So we got a kind of nice clear scene where we can preview our Honeybee exported geometry. So if I plug in our Honeybee model to this HB Visualize by Type, well, all right, well, we'll see that actually what we're getting at first is maybe not exactly what we expected. So in this case, we didn't export it using any multipliers, so that's why we see this blank empty space in between the three floors that make up this model. But we know the multipliers are there because of what we saw coming out of this color room 2D attributes. Maybe another thing we notice is that this model has no windows in it, which probably we could have already realized that was the case. We didn't really assign windows at any point in the process of making this model. And you know what? Maybe this is something that I can quickly address right now just to make this more of a believable model for simulation. So before I go and take our building and add it to the Dragonfly model, I'm just going to add some window parameters using the same method that we did in all of our other videos. I'm going to grab, let's see, a DF facade parameters component. Here we go. From our create tab, I'll plug in our building for that. And again, I'll just use some simple, window ratio parameters. Maybe we'll say that the ratio is 0.4. All right, this is just to make our model a little more believable. And I can connect up these new edited Dragonfly objects, these Dragonfly buildings that have the windows assigned to them. These can go straight into our model. And so now we'll at least see some windows coming through here. But actually, this is starting to hint at a much deeper problem with our model right here. So actually, maybe let's make a little space here so I can maybe dissect this visualization a little more in the scene. If I turn the preview off on this HB Visualize by Type, and I'm going to connect up just the elements of the model that I want to see to a native Grasshopper geometry parameter. So I'm going to connect up the wireframe, and I'm going to connect up the apertures, which are just the windows. And you can see, oh man, there's something wrong with our model. So we're getting all of these window geometries generated along, boundaries that we know should be interior, that we know should be surfaces, right? And so we kind of can probably see as we set up this model, there was no point in this, steps of creating these individual rooms and then creating the stories. At no point do we actually try and solve adjacencies to make sure that we could tell ultimately, which of the walls of these rooms would be interior versus exterior. So that's going to be the primary focus of the cleanup efforts of the model today. We're just going to make sure that we can actually solve adjacency so that ultimately we don't get these windows being generated over all these rooms. Maybe just to drive home my point that the boundary condition is the problem. you'll see that in our model we have all these exterior walls being assigned, but practically none of them. Yeah, there are no interior walls at all in our model. So basically, we need to make sure that there are interior walls if we want this exported model to be correct and a decent representation of a real building. So all right. So first things first, what I'm gonna make this kind of full grasshopper mode, and maybe we'll make a little more space here so that it's easier enough to follow along. All right. So I think the critical point where we'd want to solve adjacency, if we're going from this hierarchy of room 2Ds, we're separating those into data trees and then joining them to stories. Probably the right place in order to insert some components that will solve adjacencies is before we've kind of left the realm of these individual rooms, and then from that point on, when we're working with stories and then buildings, this is where we probably want to insert some components to help us solve adjacency. So I'm going to zoom out. I'm going to create a little bit more space in between these two sections of my definition here. Okay. All right. And in here, if I look under the Create tab, you'll see that there are a bunch of other components here kind of on the Room 2D level before we kind of go up to stories and then to buildings, right, that are actually made to help us solve this problem of solving adjacency. And in fact, here it is. Here's a component that's just called df solve adjacency. So I'm going to drop this onto my canvas. And we'll see that this takes a list of room 2Ds, and there are a few options of whether we want to set the surface types to air boundary or use an adiabatic boundary condition instead of the surface one. But essentially, this seems really straightforward. It's very much like the way that we'd solve adjacencies with honeybee rooms. Um, Critically, though, I think we'd have to make sure that our room 2Ds are not flattened, right? Because we're plugging in a data tree of three different groups of rooms for each of the three stories that we ultimately get out of this component. So I'm going to right-click on the room 2Ds output here and make sure that we're not flattening for this purpose. And let's see. And well, I guess I could go and plug in my room 2Ds straight to this component. But those of you who are familiar with what happens in Honeybee probably know that there's one more step that we actually need to do before we can successfully solve adjacency. And that's that we actually need to make sure that the rooms are intersected with one another. Now, of course, all of these room 2Ds are just being stored as horizontal floor plates. So the way that we intersect these objects is going to be a little bit different than the way that we do it in Honeybee. But we have essentially a component that's able to do this for us. It's just right next to the solve adjacency component. There's a Dragonfly intersect room 2Ds component. And if we go and we drop this onto the canvas, we'll see that, that this will take room 2Ds and simply intersect their outer polygons with one another so that we can then successfully solve adjacencies and get matching segments between adjacent rooms. So all right, so I'm going to do this. I have to do the same thing that I did with this component. We don't want to flatten this by default. I'm just going to right-click on the room 2Ds input here and select flatten to make sure I'm not changing the input that much. And I'm going to connect up my room 2Ds to this. You'll see we still need a Boolean toggle to run, and that's because this component can sometimes take a while to run. Or it's also just a good, part in your script to if you don't want to necessarily run the rest of your script, you can easily just set the toggle to false here. But let's go and connect this to the run, and I'm going to double click this to set it to true. And so you'll see out of this component, we're getting pretty much the same thing that we plugged in, except that now we know our room 2Ds have had their segments, the segments that define their outline, the polygon outlines of these rooms have been intersected with each other so that they're matching line segments between the two. And so that means that I can take these intersected room 2Ds and try and solve adjacency with them. And in fact, I'm just going to use the same toggle that I'm using to intersect. I'm going to plug that into this solve adjacency component. All right. And so again, out of this is we're just getting a list of room 2Ds, right? Nothing really spectacular. I mean, maybe we can see that our data trees are getting a little crazier here. I could probably just simplify them, and that'll make things a little straightforward going forward. So I just right-clicked on the adjacent room 2Ds and hit simplify. But essentially, right, these are the same types of room 2Ds. We just, at this point, we should have those interior walls coming through after we've passed them through these two components. So let's go and check and verify that this is actually the case. I'm going to connect up these room 2Ds that have had their adjacency solved to our Dragonfly stories. You should just have the rest of the script run normally as we did before. And, maybe I can actually just group all of these because these are all part of the process of kind of preparing those rooms before we create the stories. And if I go over to my Rhino scene, yeah, okay, this is already looking a lot better, right? So if I go back to the components I'm using to visualize by type, I think I should now find, here we go, we have interior walls coming through, all because right back here, before we went and created our Dragonfly stories, we made sure to intersect those room 2Ds and solve adjacencies between them before we went ahead forward. And the kind of beauty of this, you guys see that we can do all this intersection just with the pure Dragonfly objects. When we do intersections in Honeybee, we have to intersect the geometry even before we convert it into a Honeybee room. With Dragonfly, we have methods all built in to just work with the room 2Ds themselves. So this should make it much easier for you to set up models, that have this type of zoning and interior walls like you see here. Okay. So, all right. So I think, and I just want to verify as well that our apertures, right? We can see now our apertures are only being generated on those exterior windows. And, maybe I can go back to seeing what the whole thing looks like. I'm just going to turn the preview back on our visualize by type. And yeah, and this is looking much, much better, right? This is looking much more closer to what we'd expect for our geometry being exported. Maybe just to make sure that I really understand what this full model looks like, I'm going to set the use multiplier to true on this component that's exporting the Dragonfly model over to Honeybee. So, I'm sorry, I want to set the use multiplier to false. The default is true, I forgot. So when I don't use the multiplier, that should ensure that we now get detailed, yeah, look at that, nice detailed 3D geometry for the entire building. And I think altogether this is something like 600 zones here. This is a really big building. I mean, and considering the fact that we were able to build such a large model with, it's still probably under, I want to say like 10 Dragonfly components are being used really to create this really sizable model here. You can hopefully get a sense of the power of working in Dragonfly as opposed to having to build up a model this size just working in Honeybee. Maybe I can even, I can add plenums. I'm going to copy and paste this toggle so you guys can see what happens when we add ceiling plenums in here if we don't like to have these gaps from one story to the other. Wow, all right, we're really, really fleshing out the detail here. But there's one other thing I'd like to do, which you guys could probably guess. I pointed it out with all of our other models. And that's the fact that we still have adiabatic boundary conditions being used for all of these ceilings. All of these floors and ceilings from the roofs here and the ground surfaces here. So in order to do that, in order to make sure that we have a ground and roof boundary conditions, we can use the same component that we used in other workflows. So that would be this Dragonfly separate top and bottom component. So I'm just going to, before I go and add my buildings to my Dragonfly model, I'm going to pass the building object I have here through this DF separate top and bottom. I'm going to connect up the building to here and then connect up the resulting building that I have to the Dragonfly model. And you'll see, at least initially, that'll make sure that the top story is getting our roof boundary condition, the bottom floor is getting our ground boundary condition. But because we didn't separate the middle floors, you can see, right, we're still getting adiabatic boundary conditions used for these geometries. These middle stories. So if I just set a Boolean toggle to true for separate mid, I think that should give us exactly what we want. So double click the canvas, type Boolean toggle to true, connect that to separate mid, and give it a few seconds to run the translation to Honeybee. And yes, lo and behold, I think we now have a model that is really a good representation of a real building. And in fact, you can see that the model is smart enough, right? The only exterior roof geometries are just these, if I look at these roofs coming out here and the wireframe, and I turn the preview off here, right? You see it's smart enough, this separate mid process is smart enough to only separate out the roof geometries for these room 2Ds that have no geometry above them. That all of the other ones are still getting interior types of boundary conditions. And you know, while I'm still looking at this red color, I'm just going to change the wires to be black. The easy way to do that, you can just, you know, what I did here is click on these document preview settings in Grasshopper, and you can change the value to be down to 0 and the saturation to be 0. So all right, so this is a little bit clearer, I think, right? You can actually see what is the outline of the building versus the, you know, the actual roof geometries. So, all right, so great. We've got the boundary conditions being set up correctly. I mean, and you can see, yeah, take a look at those nice interior walls again with the wireframe, right? This all looks like the way I'd expect it to be. Um, so let's see. I mean, there are a few other things I might want to tweak before I really send a model like this off to be simulated. Let's see that you can. Let's see, I didn't really assign a construction set for this model. So, I mean, we assigned construction sets for our last two models, so I'm not really going to be doing that here. But the place where I'd recommend this, you'll notice that you can assign construction sets either on the story level or even on the individual room 2D level if you want to just say that this particular room has this particular set of constructions. But, I mean, more often than not, we want to use the same set of constructions over a whole building. And so you can specify that on the building level here. That's probably how I'd recommend setting a construction setup for this building. As far as that, I mean, I think we're mostly, you know, this is pretty much a simulatable model. Maybe we'd also want to assign a detailed HVAC system to it, like, you know, like a VAB system that'd probably be suitable for this office here. But we already covered that a few videos back when we built the model from building footprints that we simulated. So I'm not going to cover that again here. Other than that, though, this is pretty much a ready-to-go model. In the link, I can give you a sample file of like a fully detailed version of this whole workflow with the construction sets and with the HVAC system assigned. And you guys should definitely feel free to open that file and test out the simulation. If you guys do run a simulation with this, I'd really strongly recommend, you know, instead of exporting the, you know, entire building to a single honeybee model, it's probably going to be much nicer to export each story of this model as a separate building and then as a separate honeybee model and then run that in parallel. And the easy way that you can do this is just by setting this object per model to be equal to story instead of the default, which is just building. So to give you guys a sense of what this will look like, we can plug in story. Whoops, I need to put story inside a panel. So I'm just going to type double quote and then story. And you guys will see, I mean, it's going to be a little bit of a messy visualization at first, but if I connect the story to the object per model here, instead of getting a singular model out of this with, you know, where everything is in one big, basically dumped into one big model, now I'll actually get each and every individual story. All of these 20 stories are being exported to a separate honeybee model. And there are ways to run the simulation in parallel so that you know, you can run each model on a separate CPU. And that way at the end, you know, that's going to be, you know, 20 times faster almost than running the whole model as a single entity, running all 600 zones together. So, I mean, maybe just so that you guys can really see this, I'm going to, you know, use the list item component, list item, to select out one of these models, just so I can walk you through this one last section. And I'm going to make a slider going from 0 up to 20. And I'm going to use the Grasshopper shortcut of double clicking and saying 0 less than 20 to do that. All right, and if I connect that to the list item, you'll see it, right? I can select out of this whole list just one model that I care about. Maybe I'll turn the preview back off on this this model that I have here so that you guys can actually understand what each model looks like. So, right, so we actually have all the stories above, you know, all the stories that aren't accounted for, you know, in this individual story, this ground floor plinth. Right, they're being represented as context shades. So you're actually still accounting for the rest of the building when you export your model this way, right? And each story is still coming through with the context shades in it, right? So even though you're parallelizing the model like this, you're still accounting for the self-shading that, you know, the tower may cast on this part of the building and all of that, right? So the export process of Dragonfly to Honeybee is smart enough to make sure that this context shade still comes through. So, all right. So I think you guys, I hopefully you got a good enough sense of how to use this room to stories to building workflow to really build fully simulatable models. And to be able to customize things at a much higher level of detail than you could when you build your energy models from solids or from footprints. Um, Again, I have a fully detailed sample of this file in the description that I'd encourage you guys to check out. And I think that about wraps it up. We've pretty much covered all of the workflows for how to create Dragonfly models. In the next few videos, we're going to talk about some of the other cool things you can do with the energy results that you get from your Dragonfly models. And we're actually going to go back to the from building footprints example that we finished a few videos ago. So thank you guys for sticking it out through all these videos, and I look forward to digging into some new types of analyses in the next video.